Hello friends, thank you for watching this video. I believe you will find it helpful and informative. And if you have not subscribed, I will encourage you to kindly hit the subscribe button to get notification when I post helpful content. Yeah, so let's just go straight into um, this problem. So first of all, you might want to just try the problem. These are just about 20 problems. Yeah, just try them, try to, just solve them by yourself and see what you get. And at the end of that, you can just look at the solution to this problem. So let's just jump right into solving the problem. So for problem number one, we want to differentiate the function. So if you have a function like this, you observe that this is a product of two functions, this function right here and this other function right here. So this is the product of two functions. So what readily comes to mind is using the product rule. But in this situation, the product rule might not be the most efficient method, because when you are taking JAMB, you don't only want to solve the problem correctly, but you want to also maximize the time. So to solve this problem, we can just use the power rule. But to use the power rule, we can rewrite this problem as x to the power of 2 over 3 times 2x minus x squared, right? And this x here is the same thing as this x, 2x is the same thing as x to the power of 1. So what I can do is that I can multiply the x to the power of 2 over 3. I can just distribute. And when you distribute, you have x to the power of 2 over 3 um, times x, which is to the power of times x to the power of 2 over 3 times x squared, right? So to combine the fraction, I know that can be, um, you know, um, that's basically the rule of indices, right? So, and I'm going to write it by the side. X to the power of n times x to the power of n is equal to the x to the power of n plus m, right? So to combine this is just going to be 2 to the power of x to the power of 2 over 3 plus 1, right? Minus x to the power of 2 over 3 plus 2, right? So one thing I can do is to make this easy, I can rewrite the 1 as what? As 3 over 3, right? And for this one, I can rewrite the 2 as 6 over 3, right? So this is just going to be 2x to the power of 5 over 3 minus x to the power of 8 over 3. Now I can apply the power rule on this, right? This is my y, right? I can apply the power rule. And what does the power rule tells me? The power rule says that if I have y is equal to ax to the power of n, y prime, the derivative is just going to be, I bring the power down, which is n. So I have a times n, then I subtract 1 from the power, n minus 1, right? So applying the power rule to this function, to this equation here, I'm just going to have um, y is equal to 2 times the power, the first power is 5 over 3, then I have x to the power of 5 over 3 minus 1 minus 8 over 3 x to the power of 8 over 3 minus 1. And to simplify this, I can rewrite the 1 as 3 over 3, right? And I can rewrite this one here as what? As 3 over 3. And the reason why I'm writing 3 over 3 is that I want to make the denominators to be the same, right? So this is just going to be, if you simplify it, you have y prime, sorry, this is my y prime. Y prime is going to be 10 over 3 x to the power of 2 over 3 minus 8 over 3 x to the power of 5 over 3. And if you look at the options, so This y prime here is the same thing as dy dx, right? So if you look at the options, the solution will be solution number, I think that's solution number 2, right? B. This is B. That's the correct one. So I hope this helps. Okay, so now let's look at this problem. This JAMB 2023. This is a problem from just, last year, right? So we want to evaluate this integral. How can we do this? Okay, so basically, when you have something like this, you want to rewrite, any expression in radical form. You want to rewrite it in the form of x to the power of something, right? So I have integral from 0 to 1, 4x minus 6. This is going to be 2 over 3, right? Dx, right? So now I can apply the rule of integral, the power rule for finding integral on each term, right? On each of these terms. So, and the power rule says that if I have integral of x to the power of n dx, it tells me that, integral is just going to be x to the power of n. The integral is just going to be x to the power of n plus 1 divided by n plus 1 plus c. And the c is because this is an indefinite integral. So, but what we have here is a definite integral, right? Because of the 0 and the 1, the limit 0 to 1. So now let's apply the power rule. Applying the power rule, this is just going to be 4x squared, right? Because the power of x is 1, right? 1 plus 1 is 2. So 4x squared divided by 2 minus 6x 2 over 3 plus 1 divided by 2 over 3 plus 1, right? So, and my limit is from 0 to 1. So this is just going to be, if I simplify the first term, I'm going to have 2x squared minus 6. So if I can rewrite my 1 as 3 over 3, and I can rewrite this one here as 3 over 3. So this is just going to be 5 over 3 divided by 5 over 3, right? And just to, this is going to be 0 to 1, and this is just going to be 2x squared minus 18. If you simplify this part here, this is just going to be 18 over 5x to the power of 5 over 3. This is from 0 to 1, and this is just going to be, so I'm going to plug in 1 first. So if I plug in 1, 2 to the power of 2 times 1 square minus 18 over 5, 1 to the power of 5 over 3, right? Minus, if you plug in 0 into all that, you get 0 minus 0, right? So this is just going to be 2 minus 18 over 5, right? Because 1 square is 1, 1 times 2 is 2, and then 1 to the power of 5 over 3 is just 1. 1 times 18 over 5 is 18 over 5. So to simplify this, what I want to do is that I want to make the denominator to be the same, because this is 2 over 1, right? So what I'm going to do is that I'm going to multiply both sides of this part. I'm going to multiply top and bottom by 5. So I have 10 over 5, right, minus 18 over 5. And this is just going to give me minus 8 over 5. And that's the solution. That's the solution to that integral. So if you check the options, the answer is just going to be B. Wow. See, the first one was B. The second one was also B. Okay. Okay, now let's look at this problem number 3. Integrate 2x plus 1 everything to the power of 3. How can we do this? Okay, so basically we want to compute the integral of 2x plus 1 dx, right? So if you see a problem like this, one thing that should come to mind is U substitution. What do I mean by that? So I'm going to substitute 2x, the expression inside the parentheses, inside the brackets, right? I'm going to substitute that expression for u. So what do I mean? So I'll say let u be equal to 2x plus 1. Then what I'm going to do is that I'm going to take the derivative of, so I have du dx is going to be 2, right? So I'm going to have du is going to be 2 dx, right? If you cross multiply, and then if you divide both sides by 2, you have your dx is going to be du divided by 2, right? So what I'm going to do is that I'm going to write, instead of writing 2x plus 1, I'm going to write u. So this is just going to be integral from, there's no limit, so it's going to be integral u to the power of 3. And what is my dx? My dx is du over 2, right? So I'm going to just factor out the 1 over 2, right? 1 over 2 integral u of u to the power of 3 du. And now I can safely apply the power rule here, right? So this is just going to be 1 over 2 u 3 plus 1 divided by 3 plus 1 plus c, because this is an indefinite integral, right? So I have to put the plus c there. So this is just going to be 1 over 2 u to the power of 4 plus c, and this is going to be 1 over 8 u to the power of 4 plus c. But remember, my u is what? My u is 2x. I said let u be equal to 2x plus 1. So this is just going to be 1 over 8 2x plus 1 to the power of 4 plus c. And that's going to be the solution. That's going to be the solution for that problem. Okay, so now let's look at problem number 4, right? If we want to solve this problem, how can we do it? Okay, because of the fraction, the power 2 over 3, we cannot just multiply the 2 in. So how can we solve this problem? We can use the same method we used for problem number 3, right? So we can use the U-substitution. So what we can do is that we can say let u be equal to 2x minus 3, right? Now, what I'm going to do is that before I continue, I'm going to rewrite this integral as integral 2x minus 3, everything to the power of 2 over 3. Then I bring the 2 forward. I'm going to write it this way. And you are going to see the reason why I'm writing it that way. It's still the same thing, right? I just brought, instead of writing the u first in this part, I wrote the u here. It's still the same thing. So du dx in this case is just 2, right? So if you cross multiply, you have what? You have so let me bring this to the side. So if you cross multiply, you have du is equal to 2 dx, right? So now, if you observe in my integral, I have a 2 dx there, right? So, and I have a 2 dx here, right? So instead of writing 2 dx, I can actually just write du. So this is just going to be, this integral is just going to be integral from integral of u to the power of 2 over 3 du. Okay, so what I just did here was, instead of writing this 2x minus 3, I wrote u, right? I substituted. That's why they call it substitution. So this is just going to be equal to, so if you apply the rule of integral, which is you add 1 to the power and you divide by the new power, this is just going to be u 2 over 3 plus 1 divided by 2 over 3 plus 1 plus c. The c is the constant of integration. And instead of writing 1, I can write 3 over 3, right? To make the denominator the same, right? 3 over 3 is the same thing as 1. So this is just going to be u to the power of 5 over 3 um, divided by 5 over 3 plus c, and this is just going to be um, this is just going to be 3u to the power of 5 over 3 divided by 5 plus c, right? And this is going to be 3, instead of writing u now, right? Because I said let u be 2x minus 3. This is going to be 2x minus 3, 5 over 3 divided by 5 plus c. And this is going to be the solution. This is going to be the solution to that. I hope this is helpful. Okay, so now let's go to the next problem, which is we want to find the derivative of this function, this equation here at x is equal to -1. So if you see a problem like this, one thing that comes to mind, just like I said in problem previously, is the product rule. But there are some situations whereby the product rule is not necessary. So in this case, I can just simplify that expression. So I have my y is equal to, so this is going to be, if you multiply this and this, you get 4x to the power of 3 minus 2x squared, right? If you multiply 2x squared times 2x, you get 4x to the power of 3. Then 2x squared times minus 1 is just going to be 2x squared. So the derivative of that, which is your dy dx, is going to be 12x squared minus 4x, right? So now at x is equal to -1, so this is dy dx at x is equal to -1. So basically, let me erase this. So dy dx at x is equal to -1 is, I have dy dx at x is equal to -1, meaning I'm going to plug in -1 inside whatever I got, minus 4, -1. And -1 to square is just going to be 1 because that's an even power. So I have 12 times 1, which is 12. Then this negative times negative is positive, plus 4, this is just going to be 16. And that's the solution to that. The answer is 16. I hope this helps. And if you observe that this particular problem came out in JAMB 2021 and also JAMB 2004. Exactly the same problem. They repeated the problem. So yeah, so just practice very well. Okay, now let's look at this problem from JAMB 2004. So we want to find the derivative of 3 cos x divided by 3 when x is equal to 3 pi over 2. So how can we do this? Recall that if I have y is equal to cos x, the derivative dy dx is what? Dy dx is negative sine x. Also, if my y is equal to cos ax, dy dx is going to be negative a, the constant a is going to come out, then I have sine ax. So this, recall this, right? So we are going to apply this here. So in this case now, my y is equal to 3 cos x over 3, right? So I have y is equal to 3 cos, so I can write this as 1 over 3 times x, right? So if I take the derivative, dy dx is going to be 3, then the constant, which is this constant here, which is 1 over 3, applying what I have here, right? So this constant here is going to come out, so I have 1 over 3. But remember, since I'm taking the derivative of cos, there have to be a minus, then I have sine 1 over 3x, right? So if you simplify this part here, what are you going to get? You will get -1 sine, so sine basically x over 3, right? So now, but the question says when x is equal to 3 pi over 2. So let's plug in 3 pi over 2. So you have dy dx when x is equal to 3 pi over 2. So I'm going to plug in negative sine 3 pi over 2 divided by 3. So if you simplify that, that's just going to be negative sine 3 pi over 6. And if you simplify that further, it's going to be negative sine pi over 2. And what is sine pi over 2? So how do you know? So let me draw the graph of sine. The graph of sine starts from 0 and it's like this, right? So this is a full revolution. This is 2 pi, this is pi, and pi over 2 is just half of this, right? Half of it from here to here, half of that. So this is 1, right? So pi over 2, so pi over 2 is 1, right? So this is just going to be negative sine pi over 2 is 1, right? So your answer is actually negative 1, right? Because, yeah, so your answer is just negative 1. Yeah, I hope this is helpful. Okay, now let's quickly go to the next problem. So I want to find the derivative of this expression, this equation here. Basically, you just apply the power rule for finding derivative, which is you bring down the power and you subtract 1 from it. So this one is going to be direct. Dy dx is going to be 6 times 3, because 6 times 3x, 3 minus 1 is 2, plus 2, negative 2x, negative 2, negative 1, minus negative 3x, negative 3, negative 1. So this is just going to be 18x squared minus 4x minus 3 plus 3x minus 4. And that's going to be the solution to that problem. Yeah, I hope that is helpful. Okay, and you have to be careful with the signs so you don't mix it up, like plus times minus is minus, minus times minus is plus. You have to be very careful with that. Okay, let's look at this problem. We want to integrate this expression here. So we want to apply, basically you just apply the power rule for integration, which is you add 1 to the power and you divide by the new power. So if you add 1 to the power, so this is just going to be 4x negative 3 plus 1. So I'm going to write it plus 1 divided by negative 3 plus 1 minus 7x 2 plus 1 divided by 2 plus 1 plus 5x 1 plus 1 divided by 1 plus 1 minus 6. If you integrate a constant, you just get x, then plus c, because this is an indefinite integral. So this is just going to be equal to 4x negative 2 divided by negative 2 minus 7x to the power of 3 divided by 3 plus 5x squared divided by 2 minus 6x plus c. And if you simplify this further, you get negative 2x to the power of negative 2, negative 7 over 3x to the power of 3 plus 5 over 2x squared minus 6x plus c. And that's going to be the solution to that problem. Hope you're enjoying this. Okay, let's move to the next problem, which is we want to find the derivative of log 4x cubed minus 2x. So what's the derivative of this? Now, before we do this, I just want you to note that the derivative d dx of ln x is equal to 1 over x. Okay, and you should also note that d dx of ln ax, so, or maybe if you have something like this, it's going to be the derivative of what is inside here, right? The derivative of what is inside here. So the derivative of what is inside here is just going to be a, because a is a constant, right? Divided by divided by x basically, right? Divided by, yeah. So let me erase this. Divided by, so it's gonna be ln ax is gonna be derivative of what is inside here, which is ax, right? So it's gonna be derivative of that is gonna be derivative of ax is a divided by ax divided by that thing exactly. So this is just gonna be 1 over x. I hope I'm doing that correctly. Okay, so if you want to do that, let's just use the U-substitution to clarify. So this is ax, right? So let u be equal to ax, right? So du dx is just going to be a, right? So I have ln u, right? And the derivative of ln u is just 1 over u, right? So it's going to be times a, which is so I have u, because my u is ax, so I have ax. Okay, so I'm correct, 1 over x. Okay, so now for this one, now applying that, the derivative of, so what I'm going to do is I'm going to take the derivative of what is inside here, right? So just a quick way is just take the derivative of what is inside there, which is the derivative of that is going to be 12x squared minus 2 divided by exactly that thing, 4x cubed minus 2x. And I can factor out 2 in the numerator, so I have 6x squared minus 1 over, I can factor out 2 in the denominator, so 2x cubed minus x. Okay, and this is just going to be 6x squared minus 1 divided by 2x cubed minus x. And that's the solution. So basically, let me just explain what I did. So basically, I just took the derivative of what is inside the log function. This, I just took the derivative of this and I divided by that exact thing. So it's kind of like what I have here. So for this one, I took the derivative of this, then I divided by exactly that same thing, right? And I simplified. So, and that gives me my answer. Okay, so now let's move to the next problem, which is find the derivative of this equation. S is equal to 4t plus 3 times t minus 2 at t is equal to 5 seconds. So the s dt. So before I do this, instead of using the product rule, I can just distribute, right? I can just multiply 40 times t and 40 times negative 2 and 3 times t, 3 times negative 2. So let me rewrite my s. My s is going to be 40 times t is going to be 4t squared, then minus 8t, then plus 3t, then minus 6. So if I simplify this, I have 4t squared minus 5t minus 6. So if I apply the power rule on this new expression, so I'm going to have 8t minus 5, because the derivative of a constant, which is the derivative of this negative 6, is going to be 0. So ds dt at t is equal to 5 seconds. So I'm just going to plug in 5 into that. Minus 5 is going to be 40 minus 5, which is 35. And that's the answer. I hope this helps. Okay, so let's keep moving. Now I want to find the derivative of want to find the second derivative of this equation, this function rather. So the first derivative, just using the power rule, dy dx is going to be, so 8 times 3, that's what? That's 24x squared minus 6x plus 7, right? And just take the second derivative of this, d square y dx squared is going to be 48x minus 6, and that's the solution to that. I hope this helps. Okay, so now let's integrate this, right? Let's integrate this. So this one is not complicated. We just use the power rule for the integration. So this is just going to be, so you have 2x cubed divided by 3 plus x squared divided by 2. So I added 1 to the power, I divided by the new power. So this is going to be from -1 to 2. And so I'm going to plug in 2 first. So I have 2 over 3. I'm going to plug in 2 cubed minus 2 plus 2 square over 2. Then I have minus, then I'm going to plug in minus 1 cubed plus minus 1 square, right? So if you simplify this is going to be, this 2 cubed is 8. 8 times 2 is 16 divided by 3, right? Plus 4 divided by 2 is 2, right? And I have minus -1 cube is -1. So I have -2 over 3. Then I have plus 1 over 2. Okay, so now what I can do here is that I can multiply this side by 3 over 3, right? And I can multiply this one by 2 over 2. So I multiply this one by 3 over 3 because I want the denominator to be the same. So what I'm going to do is that I'm going to have, this is going to be 16 over 3 plus 6 over 3 minus, I have minus 4 over 6 plus 3 over 6. So this is just going to be, 16 plus 6 is what? 16 plus 6, that's going to be 20, that's going to be 22, right, over 3 minus, so I have -1 over 6, right? So this is just going to be 22 over 3 plus 1 over 6. So what I can do is that I can multiply this, the first part by 2 over 2, which is 1, right? So this is just going to be 44 over 6 plus 1 over 6, and this is 45 over 6. And that's my solution. I hope this helps. Okay, so we are making good progress, right? We are making good progress. So let's look at the next problem, which is problem number 13. Problem number 13. So we want to integrate 6x to the power of 6x to the power of and I think for problem number 12, before we move to problem number 13, for problem number 12, we can simplify that further. To be equal to 15 over 6. I mean 15 over 2, sorry. 15 over 2. Okay, because sometimes your answer might be in the lowest form. Okay, so now for problem number 13, so we are going to want to integrate this. So you have integral of 6x squared minus 2x plus 1 dx. So we just apply the power rule. This is just going to be 6x cubed over 3 minus 2x squared over 2 plus x plus c. So if you simplify that further, it's just going to be 2x cubed minus x squared plus x plus c, and that's it for that. Okay, problem number 14, just the same thing, just apply the power rule for integration. It's going to be x cubed, you add 1 to the power, plus 3x squared over 2 minus 5x plus c, and that's going to be it. Okay, problem number 15, So this one, what I'm going to do is that I'm going to bring out the 5 out. I'm going to bring out the 5 out, right? And I have 1 over x dx. Okay, recall that the integral of 1 over x is going to be ln absolute value of x. So this is going to be 5 ln absolute value of x, right? But recall that I'm moving from my limit is going to be 1 to 2, right? So this is just going to be 5 ln absolute value of 2 minus ln absolute value of 1, right? So now the log of the natural log of 1 is 0, right? So this part here is 0, right? Now if you look at the way the answer, the options for the answer, you know, you might like, how will I know? Okay, so since ln 1 is 0, ln 2 is going to be maybe like 0 point maybe 7 or something, 0 point maybe 8, you know, because ln is going to be is increasing. So this is going to be like 0 point maybe 7 or 0 0.8. And when you multiply that by 5, you know, when you multiply that by 5, you get something that is big, which is you get this 3 points. You get times ln absolute value of 2. Ln absolute value of 2 is going to be like 0 point, you know, maybe 0 0.7 or 0 0.8. And when you multiply that by 5, you get approximately 3.47. So this is a kind of a tricky, you know, question, right? So okay, so like now let's differentiate this function, this expression, this equation. Sorry. So now if you see something like this, if you see something like this, right? You might say, oh, the quotient rule, let me apply the quotient rule. But wait a minute, the quotient rule might not be necessary because I can rewrite um, this expression as x squared divided by x minus 1 over x, right? So if I simplify, I'm going to get x minus 1 over x. And this is going to be x to the power of negative 1, right? I can rewrite 1 over x as x to the power of negative 1. So dy dx is just going to be the derivative of x is 1 minus, derivative of x to the power of negative 1, I can bring down the power negative 1, x negative 1, negative 1. So this is going to be 1 plus x negative 2. This is 1 plus 1 over x squared. And that's the solution. That's the derivative. Okay, how about question number 17? Question number 17, so now you need to note that the integral of sine is negative cos. The integral of sine, so note that the integral of sine of x dx is what? Is negative cos x plus c. So, and also the integral of sine of ax dx is going to be what? It's going to be negative cos ax divided by a plus c. So note that that will be very helpful. So if you know that, then you can easily guess the answer to this problem. This one is just going to be negative cos 3x divided by 3 plus c. Okay, I hope that is clear enough. Now let's look at this one, this problem. Okay, so now if you have a problem like this, you want to determine the area of the region bounded by these curves. So the first thing you want to do is that you want to equate the the two the two curves, right? You want to equate these two equations, you equate them and you solve for x. So if you have 2x squared plus 10 equals 4x plus 16. So what I'm going to do, I'm going to bring all the expression, all the terms in the right hand side to the left hand side. So I have 2x squared plus 10 minus 4x minus 16 equal to 0. And this is just going to be 2x squared minus 4x plus, sorry, minus minus 6, let me use a black color, 6 is equal to 0. And when you solve this quadratic equation, what you're going to get, you're going to get x is equal to -1 or x is equal to 3. You solve that quadratic equation. Okay, so now that you have x is equal to -1 and 3, so basically you have an interval from -1 to 3. Now what you want to do actually to compute this area, what you actually want to do is that you want to compute an integral, right? You want to compute an integral, which is the difference of these two expression. But the question is that which one will come first? So what I'm saying is that you want to compute integral of from -1 to 3, because that's what we got when we solved. If you solve this quadratic equation, you're going to get x is equal to -1 or x is equal to 3. So now it's going to be integral from -1 to 3 of either this 2x squared plus 10 coming first minus 4x plus 16, or 4x plus 16 coming first minus 2x squared plus 10. But how do we know which one will come first? The way we can figure out which one will come first is, what we are going to do is that we are going to take a number from this interval, right? So a number from this interval is x is equal to 0. So and we are going to plug it in. So if I plug this x is equal to 0 into this first one, right? So if I plug in x is equal to 0 into that, what you are going to get is that you're going to get 10, right? And if you plug in x is equal to 0 into this second part, right, what you're going to get 16. So 16 is greater than 10, right? 10 is less than 16. So that means that 4x plus 16 is going to come first minus 2x squared plus 10. So you're going to have this, we're going to compute this integral. So if you compute this integral, -1 to 3, so you have 4x plus 16 minus 2x squared minus 10, right? If you compute this integral, so let me simplify. 6 minus 10 is going to be -4, right? -1 to 3, so I have 4x minus 2x squared minus 4 dx, right? And these are, if you compute this integral, you have 4x squared divided by 2 minus 2x cubed divided by 3 minus 4x. And just as we have been doing before, you plug in 3 first, and then you plug in -1, and then you just simplify. And if you compute this integral, what you're going to get is you're going to get 64 over 3. You just plug in 3 into that, minus, you plug in -1 into that, and you simplify. You're going to get 64 over 3. Okay, now let's look at this problem number 19. We want to evaluate this integral, right? So want to evaluate this integral, basically you apply the power rule, right? And this is just going to be x cubed divided by 3 minus x, right, from 1 to 3. And this is just, you plug in 3 cubed divided by 3 minus 3, then minus 1 cubed divided by 3, which is 1 minus 1. If you simplify all this, 27 divided by 3 is 9 minus 3 minus 1 over 3 minus 1. We have to be careful here, right? You have to be careful. If you simplify everything, you get 20 over 3. Simplify everything, you get 20 over 3. And lastly, we want to find the derivative of this equation, which is y is equal to sine square 5x. So this is the same thing as sine 5x square, right? Remember, if you have a square is the same thing as a times a, right? So this expression is the same thing as sine 5x times sine 5x. And what I can do is that I can apply the product rule. The product rule tells me that I will take the derivative of this one then I'll keep the other one constant, plus I'll take derivative of the other one and I will keep the first one constant. So the derivative, which is dy dx is going to be, the derivative of sine 5x is going to be 5 cos 5x. Then I'll keep this part constant, this part here, right? So this is just going to be, so I have sine 5x plus, I'll take derivative of the now I'm taking the derivative of this part now, right? This part here, and it's the same thing, right? It's just going to be 5 cos 5x times, I'll keep the first part constant, this part, right? So I have sine 5x, right? If you observe that both sides are the same, exactly the same. So it's kind of like I have, if you have 5a plus 5a, that's equal to what? 10a, right? So this is just going to be 10 cos 5x sine 5x. And that's it. I hope this is helpful. So if you have not subscribed, I will encourage you to subscribe so that when I post more videos, you can get it. I hope this is helpful. I wish you the very best in your exam, in preparing for your exam. Thank you.